All right, Unit 13, Day 1, Part 2. Again, we're doing 2 parts to buy us some time so that we basically can play catch-up day tomorrow, day before spring break. This is us paying it forward, earning a day off. All right, let's again start with triangle ABC. Little a across from big A, little b across from big B, little c across from big C. Part of the law of cosines formula you already know. And so memorizing law of cosines is sort of adding on to a formula that you already know. C squared equals, yeah, your brain just like reflexively knows, oh, a squared plus b squared. Pythagorean Theorem. Except we have to be careful. When is it okay to use the Pythagorean Theorem? What is that good for? Right triangles. It's only good for right triangles. So if I leave this is not right, what I've written right here, because this is not a right triangle, so this doesn't apply. So this is great, but it doesn't fit this because this triangle is not a right triangle. Well, somebody figured out a way to sort of adjust this formula to make it work for all triangles. Obviously, it's going to be more complicated because this is a little bit more complicated than a right triangle. Here's the extra stuff. Minus 2ab cosine of angle C. And now you know why it's called law of cosines, because it uses the cosine rather than a sine. And probably the most important thing to remember, who goes where with all the letters and angles. The side that's by itself on one side, that's the angle that you'll use on the other side. Or if you know you're using a certain angle, then that's the side that's got to go by itself on the other side. Now, because this is not just for right triangles, it doesn't matter where C is, right? Like back with a squared plus b squared equals c squared, like the rule was, hey, that's great, but C is always the hypotenuse, always the longest side. We don't need to worry about that anymore, which also means we could write the same type equation for the other two sides. So b squared equals a squared plus c squared minus, what do you think is going to come for this one? 2ac cosine angle B. Right, so it's sort of the same, sort of not the same. And so textbooks always present this as like, oh, there's 3 different law of cosines equations. You're like, not really. There's one, and then you can kind of rearrange things and put letters different places. Why don't you see if you can write the last one where a squared equals something? I'm not even going to pause because I bet you can do it pretty quick. A squared equals b squared plus c squared minus 2 times the two sides that are on this side already times the cosine of the angle opposite the other side. Another way to say it is angles and sides are opposite of each other in the picture. Angles and sides are opposite of each other in the equation. Again, we're not going to give that to you, but you're going to use it often enough that I hope that it just kind of gets stuck in your brain, an accidental memorization. All right, which to use? Pardon my handwriting there. Which to use? Sines versus cosines. Kind of mentioned this already, but we'll go through it again. If there's two angles, it's law of sines. If you know two sides or more, like you look at the law of cosines equation, it has a lot of sides in it. So if you have a lot of sides, you're using law of cosines. Second way to think of it, more angles use sines. More sides use cosines. I mean, that sort of matches the same thing as number one. A third way to think of it, again, you don't even need to know all of these, as long as you know one of them to know which law to use. If you know an angle side pair, meaning across from each other. If you know a pair that's across from each other, which one do you think you would use based on the formulas? If you know an angle side pair, that would be law of sines. If you don't know an angle side pair, then cosines. I think that's kind of my go-to method. I draw the picture. If I see an angle side pair, I immediately thinking, okay, I can use law of sines. Because I'd really rather use law of sines because it's easier. Law of cosines is, it's not hard. There's more stuff to it. So usually that last one is my method for figuring out which one to use. If there's a pair, go with sines. If not, go with cosines. Tori?
Are we supposed to use SSA?
So SSA is ambiguous case. It doesn't really work, so we usually don't even give you SSA.
So we just use the SS for law of cosines and that's it?
Well, we're not going to give you SSA. We're not going to give you a problem where you have that information.
On the which to use for law of cosines, it says SSA.
Oh, it sure does. You're right. Man, I'm not working today. My brain. Good catch. That should not say SSA because that's not good. SAS. Thank you. SSA is law of sines, but it's a special case of law of sines that we're not going to do. All right, and then the last thing about which to use is that it kind of doesn't matter because if you use the wrong one, you will realize you don't have enough information. Okay, you're not going to get the wrong answer. You're just not going to get an answer. So if you set it up wrong, you're going to quickly realize, whoops, I can't work this problem. I should have used the other one. So, that's hopefully last case scenario. But if it comes to that, it's not a big deal. You switch to the other one and you're fine. All right, let's work a problem with this. A equals 16, B equals 10, angle C equals 110. Now, it's in the law of cosines section of the notes, so of course it's a law of cosines problem. But if I just look at those, I don't really know that until I draw a picture and look for a pair. That's my method for figuring out which law to use. Okay, I don't have a pair. don't know A and A or B and B or C and C. So this is going to be law of cosines. Some of you, not sneaky people, but if you're paying attention, you kind of see that from the get-go, right? I don't have A and A or B and B or C and C. I've got all different information. So you might tell from the beginning that this is law of cosines. All right, I guess the question now is which law of cosines to use? The C squared equals, the B squared equals, or the A squared equals? Which one do you think? Why C squared? Okay, two reasons. I don't know side C, and I do know angle C. So it feels like the C squared one should be the one to use. And as weird as this looks, I almost always write the equation, start with the two that are across from each other. So I put C squared and cosine C. I know that those are in that equation. So this is sort of me working on memorizing it. Then I can fill in from there. A squared plus B squared. And then it's a minus 2 times the sides that I've already used on this side. So 2AB cosine C. So 16 squared plus 10 squared minus 2, 16, 10 cosine of 110. Now this is just a calculator problem. Be careful, you got parentheses and squareds and angles and cosines and a square root at the very end, but it's just a calculator problem. So I'm going to press pause. You see if you can type everything in, get all the parentheses in the right spot. Don't forget the square root in your answer there at the very end, and see if you can come up with what C is. So you type it all in. Don't forget to square root your answer. C equals 21.574. All right, but I haven't solved the triangle yet because angle A and angle B are still missing. So I kind of need to do that again. Well, why one more time? Yeah, because then you can do the 180 thing. If you really wanted to be extra, you could do it 2 more times and then add them together and make sure they add to 180, but nobody wants to do that. Just so we're all on the same page, do you want to find angle A or angle B? Doesn't matter. A it is. Sorry, B choosers. A got picked first. So again, I'm going to start with A squared and cosine of angle A, because I know those are across from each other. This is just how I've kind of memorized it. So the rest of this will be the B and C stuff. So B squared plus C squared minus 2BC cosine of A. Oh, this is kind of annoying because now I have to write 21.574. Okay, algebra is going to be the downfall of some of you here. I want to get cosine of angle A by itself. So what should I do first to start to get cosine of angle A by itself? A lot of numbers there. Move what over? Move it over.
The 6. The cosine. We're going to switch it to the 16 squared.
I think I want to move over the 10 squared and the 21.574 squared. And I don't want to type it in yet because I'm not ready to type it in yet. Now what do we want to do to get cosine of angle A by itself? Yes, say it. Divide. Right? The left is looking weirder, but I don't care about the left. I'm trying to get cosine of angle A by itself. So let's divide by all of that mess. Yeah, don't go to your calculator till the end. Now you're ready for the calculator. And you either have lots of parentheses to deal with, or it might be wise to do that fraction bar thing for this one, since there's squareds and all sorts of stuff going on. That's alpha F1 if you want the fraction bar. It saves you some parentheses. So the fraction bar is alpha and then F1. Okay, so the cosine of A is 0.71715. That's the appropriate face.
Now how do you plug it back into that?
So cosine of A equals that. How do I uncosine both sides?
Inverse cosine.
Inverse cosine. Right? We need to uncosine both sides, but the math word for that is inverse. So inverse cosine of answer, right? So you don't type the whole thing in again, is 44.18. Angle A, 44.18 degrees. Now you guys spoiled my fun, because usually I let classes say, oh, well, we got to do all that for B. And I'm like, yeah, go ahead. But you guys are ahead of the curve. I don't need to do that for B because the 180 thing. Angle B is 180 minus the other two. Minus the other two. 5.82. And that would be degrees. Okay, that's a really good question and a really tricky answer. The question was, after we have an angle side pair, can't we switch to law of sines? And the answer is, if you do, it's an ambiguous case, which means you might not get the right answer. So if your problem starts with law of cosines, you need to stay in law of cosines. Anytime you hit inverse sine on the calculator, you're in dangerous territory because you might get the wrong answer. So if it starts as a law of cosines problem, stick with law of cosines, because you have a 50-50 shot of getting it wrong. Usually I do this problem and we're celebrating the start of the Major League Baseball season, MLB. This year it's kind of sad because they're in a lockout, so whatever. We're still going to have triangle MLB. I guess I could have gone NBA because they're playing right now. Really, I just wanted to use letters other than ABC so that you start learning, like equations like where they are on the triangle rather than just A, B, and C. So side M is 20. Side L is 15. Side B is 8.3. What do you want to find first? Oh, it's like, what do you have to find first? An angle. Which angle would you like to find first? Yeah, it doesn't matter, like all of them.
Because it's got the lowest. No.
L?
Yeah.
L it is. Why did you pick L? Okay, there wasn't a particular reason. You just sounded convinced that L was the right one.
There's a small number, so I saw it.
So if we want to find L, again, when you see me write the equation, I'm always going to write it like that. That's just kind of how I have it memorized. L squared is across from cosine of angle L. And then the other stuff goes in between there. So the B and the M. B squared plus M squared minus 2BM cosine of L.
Does it matter what order we put the B and M in?
No.
They're being added, so it doesn't matter what order they're in. Right, it doesn't matter. And same thing here, they're being multiplied, so the order doesn't matter. 15 squared equals 8.3 squared plus 20 squared minus 2 times 8.3 times 20 times cosine of angle L. Algebra, algebra, algebra. I'm going to press pause and see if you can algebra your way to what angle L equals. So hopefully you can subtract over some things, divide by some things, and then it's calculator time. So now see if you can get it all in the calculator the right way. Type it in carefully. Inverse cosine 42.729. That's one angle that we've found. What do we need to do next? Find another one. Side, side, side is the worst case scenario because you have to do law of cosines twice, and it's like the worst arrangement of law of cosines twice because you got to set it up and then do algebra. Just so we're all on the same page, which angle do you want to find next? M it is. I'm going to show even less work this time. So I'm going to press pause, see if you can find angle M from there. So showing a little less work. Inverse cosine of that, 115. And then what do I need to do? Do I need to do this one more time to find angle B? I mean, you can, but what would be the easier way to find angle B? Yeah, 180 minus the other two. And if they're still in my calculator, I might have an easy job of this. Whoops. 180 minus that one minus 42.729. A little side note on angle M, Olivia. If we had done law of sines to find angle M, sine of M over 20 equals sine of L, 42.729 over 15, we would not have gotten the right answer. So, if you start a problem with law of cosines, stick with law of cosines. Yes, it's bad news. Yes, it's annoying, but that's the rules. Alright, so this is now worksheet 2. The odds are today's assignment. So, Thursday's assignment is worksheet 1, worksheet 2, odds. Friday's catch-up day. Odds distributes to worksheet 1 and 2. There we go. Yes, good question. And then we have spring break. Yay. Go have fun. Don't think about pre-cal. Monday we'll come back. I'll answer a few questions. Maybe we'll do a couple of warm-up questions. And the assignment will be worksheet 1, worksheet 2, evens. Which means, yes, you already know enough to do those. So if you're bored over spring break and you need something to do, knock yourself out. And then Tuesday we'll do area and review. That's worksheet 3. And then block day we'll test. So that's the plan. By the way, worksheet 4 is in the packet, but it will not be due. I'll post the answer, so you're welcome to play with it, look at it. It's the review worksheet. But do you really need a review worksheet over 3 topics? Maybe. So you got it, but it won't be due.